This is an audio description for Theme 2, Question 7, comparing features that we find on Earth with those that we can see on Mars. There are a series of images of features that we find on both planets. The aim of this exercise is to identify the similarities between these features and any differences that there might be as well. The first pair of images are of two volcanoes. A volcano called Olympus Mons on Mars and a volcano called Herdebride from Iceland. These two volcanoes are shown as aerial photographs. These volcanoes are circular in shape. They both have a summit crater or caldera. One of the distinctive features of these volcanoes is, although the top is a gentle cone shape, around the edge of the volcano, at each volcano, there are steep cliffs. These are generally an indicator that the volcanoes have been erupted into ice, and the ice has stopped the volcano from spreading and forming a complete shield shape cone volcano. Olympus Mons is over 500 kilometers in diameter. Its height is about 22 kilometers above the surface of Mars. Herdebride has a diameter of about 2 kilometers, maybe a little bit less, and its height is about 1 kilometer. The second pair of images is of two rift valleys. On Mars, we have an area called the Claritas Rupes. Rupes is a word on Mars that's used to describe an edge or a cliff. From Earth, we have the Karlsruhe, part of the Ruhr Valley in Germany. Both of these images are satellite images, and they both show an area that's about 60 kilometers from side to side. On both of these images, we see a series of parallel cracks. These cracks in the surface of the planets create a whole series of parallel valleys that are about 1 to 2 kilometers wide. The image from Mars has a very distinctively red colour, whereas that from Earth is characteristically green in different shades. On the image from Mars, we can see several impact craters. These impact craters have cut across the parallel cracks forming the rift valleys. The largest of these impact craters is maybe 4 or 5 kilometers in diameter. The next pair of images is of sand dunes. From Mars, we have a series of dunes from a place called the Abylos Undae, and from Earth, we have an aerial image of sand dunes from the Namib desert, Namibia in southern Africa. Both of these aerial images show an area that's roughly 1,300 meters across. We can see on both images that there are long parallel ridges of sand. Each of these ridges is approximately 200 to 250 meters wide. The ridges have a characteristic shape. There's a shallow slope on one side, which is the direction the wind is coming from, and there's a steeper slope on the other side in the direction the wind is going to. The shapes of the dunes are slightly different. On Earth, the dune ridges are longer. On Mars, the dune ridges are a bit more curved. We can also see on the Earth image there are a scattered collection of small shrubs or trees. There's nothing like that shown on Mars. And on Mars, we can see that the steep slopes appear to be steeper than they are in the Earth dunes. The next pair of images shows a small close-up of an outcrop of rock. One from Mars, in a location called Mount Sharp, an image taken by Curiosity rover, and the other from Earth, from a location in North Dakota in the USA. Both of these images show an outcrop of rock that's roughly the same size as a piece of A4 paper. Within these outcrops of rock, we can see small scale layers, maybe only a few millimeters thick. These small layers are tilted at an angle. We can see larger or thicker layers, roughly horizontal, that are made up of these smaller inclined layers. These are formed where there is a flow either of wind or water transporting sand and depositing it. The way the images are taken, we can see that on Mars, the flow would have been from right to left. On Earth, it would have been from left to right. But otherwise, they're almost identical. The Martian outcrop is red in colour. The Earth outcrop is grey. The next pair of images show a close-up of rocks. Specifically, show a type of sedimentary rock called a conglomerate. Both of these images show an area that's roughly about the same size as an A3 piece of paper. Both of the rocks show rounded pebbles that have been cemented together. The pebbles are a mixture of sizes, but the majority of them are perhaps 2 to 3 centimeters across. Both of these outcrops of rock look like they've been weathered. The final pair of images show unconformities. One on Mars, taken in a location called the Columbia Hills, and one on Earth, taken from Death Valley in USA. They both show small outcrops of rock, probably about a metre high. Within both images, we see two sets of layers of rock. Each of these sets of layers is tilted in a different direction. As we saw in theme 1, this indicates two complete and different cycles of deposition, tilting, erosion, and more deposition. This is the end of the audio description for question 7 on theme 2.